Accepted.
Hello, friends. Hello. Hello. Hey. What? I haven't spoken yet, and there's applause. Thank you. Thank you for coming to the last slot in the conference, which has been very busy, and it's a beautiful day outside, so I really appreciate you taking the time to stay indoors and come and listen to me talk about Battlesnake. My name is Matthew. I am going to tell you about how and why I built the world's okay-est Battlesnake, and why it is the world's okay-est, and I'm confident in saying that. So that's why I'm here, and I'm wondering, like, why you're here. So one possibility is that you saw the word Battlesnake and you thought, oh, that seems interesting. I'll come along and find out about that. I've never heard about it. It's got a cool logo. I'll just learn a bit about it. Like, brilliant. Another possibility, you saw that the talk is perhaps not entirely serious from the description, and you thought it's a good way to give your brain a wind down at the end of what has been probably a very heavy conference for you all. That's OK. Some of you may be thinking that you're going to come here and pick up some real pro tips about how to write like super cool Battlesnake tech, and I'm sorry in advance if that's you, but the doors are already locked, so you're here with me now. Question one, if you're wondering, what is Battlesnake? Has anyone here like actually looked at it and tried it and done? One person. Thank you, one person. Awesome. OK, so Battlesnake is a battle version, an online multiplayer version of the classic like Nokia phone game Snake. And it looks like this. Animated. Nice. It's typically played on a 2D flat surface, so I might refer to it as snakes on a plane. No? And it's different from Nokia Snake in a few key ways. Like, one, it's multiplayer. Two, snakes will die if they don't eat food. The bars on the right are health bars for the different snakes. If that ever reaches 0, they're going to die. They go back up to full health whenever they eat. And the rules are that the winner is the last snake standing. And I know that they don't stand, but whatever. Another really super key difference, and why I think this is a good topic to talk about at a tech conference, is that snakes are controlled by code. They're not controlled by like numeric keypad or whatever. You write code which evaluates board positions and decides what the moves should be for your snake. And to answer the question now from the title, why is mine the okay-est? So there are leagues for Battlesnake, and you take part in a league over several months. They orchestrate lots of games, and each game has 4 snakes, and there's typically one winner, 4 in, 1 out, right? So over all the games, all the snakes, there is a 25% average win rate. And I'm very pleased to say that I finished the last league with 25.1% win rate. And no one got closer to 25%. So I'm convinced that okay-est, it's not just okay, it's the most okay. I'm quite okay with that myself because I wasn't playing to win. I'll talk about why I did it in a bit. So now we're getting into the meat of it, right? I told you they're controlled by code. How do you build a Battlesnake? You don't have to use Python, in case that's what you were thinking. I wrote mine in Java. Basically, every move is controlled by an HTTP lifecycle. So you provide the Battlesnake people with a URL. Every time your snake needs to make a move, they send you a post request that has in the request body the current state of the game, and you respond quickly with a direction that you want to move in. I'll show you super quick the code that I used to do that. This is a Spring Boot application. And you have to implement 4 endpoints, right? A root one, where you return some information about your Battlesnake. And I knew immediately that I was going to enjoy doing this because any HTTP API that lets you use round bum as a parameter is going to make me happy. Start and end, you can ignore. Those are called on the start and end of each match. The key one is this move. Every time there's a move. So what we saw there were maybe like 30 or 40 moves. So that's 30 or 40 HTTP requests to this endpoint. And they pass you in this game state. And this was like the first thing that I did to teach myself something new about Java when I was building this, because I decided to use records. And the game state, like JSON object, is quite big and blobby. It's actually more lines of code than this record's description of what they send you. And you'll see like no annotations or anything. I found it like really pleasingly easy to deal with records as a way of serializing JSON in and out of my app. So that was a cool thing. What they pass you is some details about the game, like whatever, you don't need to know about that. What turn you're on, like obvious what that is. They pass you a board object, which describes like what's on the board at the moment, and a Battlesnake object, which describes you. Now, you're on the board at the moment, so there's already some redundant information in here. But anyway, inside the board object, there's a height and width. Boards are square. They have walls, so you know where the edges are. They are square. They've always been square in my experience, but they still have height and width separately, whatever. List of coordinates, just x, y pairs of where the foods are. A list of Battlesnakes, which does include you, but it also includes all the other ones. And some hazards, which are used in a game mode that I'm not going to talk about, so we'll just ignore them. And then when it comes to a Battlesnake, they have an ID and a name, a health, a list of body segments, a head, which is also the first thing in the list of body segments, so that's OK. It's an array, not a list, sorry. A length, which is the length of this array as well, so that's also redundant. Latency, we can talk a bit about why that's important maybe towards the end, but you do have a time limit about your response. You can shout things as a snake. It's not surfaced through the UI, so I don't know why they let you do that. And there's like a team multiplayer mode, which is captured in this squad. You have a squad name. OK, so first thing is like I really enjoyed learning about using records, and this I found like a super smooth code path. So you've got this. Sorry, just nip back over here. There's one more thing to show. Oh, I've got a screen down there. I'm doing some like logging to system out, which is my favorite logger, and you have to return a move, and a move is literally left, right, up, or down, right? So I'm not going to bother going into it, but it's another record. This is an enum with lowercase values because that's what the JSON expects, and I don't mind because I'm the only person using this code base, so it's OK. We don't need to worry about that. So you need a public URL. You have a 500 millisecond normally end-to-end limit. So that's not you servicing the HTTP request. That's end-to-end, including latency. So pay attention to what region you're in. Don't bother doing like multiple transatlantic hops, because that will take more time. Hosting on the cloud is fine. I have like 5 different Battlesnakes all running on one T1 Micro on AWS, which is a free tier thing because I'm cheap. And it's fine, like, honestly. I'll talk more about like computationally expensive Battlesnakes later and why and how they're better. But localhost is convenient for development. You still need a public URL, and I don't have this computer like publicly addressable from the internet, so I use a couple of techniques for that. One is a tool called ngrok. Who knows ngrok? Woohoo, ngrok crew. Ngrok is a command line tool. You run it, you say ngrok http 8080, and it gives you back a public URL that forwards requests made to that URL to your local host 8080. That's cool, but ngrok sometimes suffers from like latency problems and sometimes can even be overloaded and return like 429 too many requests, in which case your snake's going to be dead. So another way I sometimes do it is SSH port forwarding. So you might be knowing SSH as a way of connecting to a terminal and a remote server rather, and using vi to edit a config file or whatever. But you can also use this -big R option, and what that's saying is, on the remote server, open port 8081 and forward requests from that to my local host 8080. The cons here are like, you need a server to SSH to, T1 Micro, and you need to keep the SSH connection alive. SSH connections will time out or like be cut sometimes through lack of activity. You can configure it to behave differently. But that's it, right? So let's have a look at the challenges mode. So before we get into battles, there's a challenges mode with Battlesnake. Right? And I'm going to show you what happens, just to prove that it works, with my, no, not that one, the snake that moves right. The point is, I need to survive 100 moves on this board. No, right? Obviously. It's just going to move right. It's going to hit the wall. Like, it's dead. But at least it works, right? We get responses. We do move right, so that's good. Probably we're 90% of the way there. What we need to do is just sometimes move in different directions than right. Oh, no, that's actually quite a tricky problem. Where's my cursor gone? There it is. OK, so that's, oh, no, sorry, cursor. There we go. That's version 0. Like, at least it works. I'd like to introduce you to my Battlesnake version 1. Don't die immediately, right? And so what we've got now is like the mandatory infrastructure. You need to deal with these requests and responses. You need to have the right JSON formats for those two things. So you need what I've shown you so far. Everything from now on is a choice, an implementation that I have decided to do. And it went OK, as we saw. So when you start getting deep into Battlesnake kind of lore and reading up, spending all your evenings on it, you'll find there are several like macro, like high-level approaches to building Battlesnakes. The simplest and probably the one that most people will start with is called a rules-based agent, where I basically, well, a rules-based agent basically evaluates the board using a gigantic number of if-elses, like if there's a snake there, move that way, if there's food there, move that way, right? And that's like, you can imagine how it ends up. But it's kind of simple because I feel like that's how I think about it, or at least I can consider like parts of it in isolation. Like if there's food there and I'm hungry, I need to go towards the food, that kind of thing. I'll talk about like other and probably better ways to write Battlesnakes than rules-based engines later. But here was how I decided to start it, right? Enumerate all the legal moves. Right? Not every move is legal. Ones that take you off the board, you're going to die. Ones that take you into the body of another snake, you're going to die. Ones that take you into the body of your own snake, you're going to die, right? So not all the moves are legal. Some of them are, though, hopefully. Otherwise, you're in trouble. So once you've got an idea of what the possible moves are that won't just immediately kill you, then I use a bunch of what I call strats, which is obviously short for strategies, to score each move, like independently considering whether this one moves me towards food if I need food, or whether it moves me away from another snake that might kill me, or whether it moves me away from the edge because the edge is a pretty sketchy place to be in general, right? So this is my, my approach. First thing I did was introduced a few more lines of print line debugging, and an interface called Move Decider with one implementation, because that's how I roll as a Java developer. Move Decider, the contract here is you give it a game state and it gives you back a move. But it's an abstraction. Like there could be multiple different move deciders, right? The move decider I started with is yoink up here, this one. Oh, let's start here, right? So we passed in a game state. And the first thing about the game state is it's like a very literal description. There's a snake here. There's a food here. It doesn't actually answer the question of like what's here. And that's often what you want to know, like what's immediately above me? Is that a safe place to move on to? So the first thing I did is parsed that into a thing which my imagination let me call a parsed board, and then just pass that down here, right? Now, what moves are even possible? And I tried out using var here because this type name's super long because it's like a nested collection of like collections of collections. But the point is it's ultimately a map. So we have a number of possible moves. And we can use, this was my third experiment with like something that I don't use very often in Java, a switch expression. So this is a switch expression with the arrows instead of the colons. And it evaluates to a value, so we can return it directly rather than having to use a switch statement, which has to rely on side effects with what you can do, right? So this was like, maybe you've all used switch expressions before, I don't know. Who's using switch expressions on the regular? Nice. I'm using Java 18 for this. I can't remember exactly what version switch expressions were added in. 17? OK, cool. And records were 14, weren't they? var was 10, so I'm really like trying to keep up. And so here's what we do, right? If there are no possible moves, then, well, I've decided to return up here. I could have returned null, because there's basically nowhere we can go. But I'm not a monster. I'm not going to return null. I decided the appropriate move for a snake here was, we're about to die, so like just look towards the sky and like accept our fate. It doesn't matter which way we go, right? If there's only one possible move, then we don't need to do any clever thinking. We just take it. Oops, we just take it. And that's like the concise Java way, apparently, of taking the key out, the only key out of a map of size 1 and returning that. Otherwise, I'm not going to walk through all this code, OK? Don't panic. But otherwise, we choose the best one. And I'm going to just go one more step here and say, look, we've got a list of these strats. And the only one in that list at the moment is random strat, right? Which you take a board in, a potential next move, and just score it randomly, right, between 0 and 1. But the point is, it will never choose a move that will kill it straight away. So this snake should actually be at least capable of not dying straight away, right? That's why the version 1 has the name it does. So let's try that again. And whilst I'm doing this, I've got a quiz for you. Gosh, I can't read those tiny things. Move random, that's the one, yeah. Is there any way whatsoever that this snake can fail to complete this challenge, apart from like HTTP failures? Yeses? Nos? So this snake never grows because it never eats. It only has to survive for 100 turns. Now, I am pretty sure, right? I think this snake cannot possibly fail, right? It's not long enough to crash into its own tail, and it never gets any longer. And if we've told it by saying only move on to empty squares, that it has to stay on the board, right? So that's it. The next challenge, so that's challenge 1, like don't run into the walls and kill yourself like that. Challenge 2, I'm going to just pause this just a second, is the same challenge, but on a bigger board with a slightly longer snake, right? Is there any way that this snake can fail to complete this challenge? I'm seeing some nods. Is anyone no? Is anyone voting no? Good stuff. Anyone who's voting yes? There's a lot more yeses, and I didn't see it coming, but the yeses are correct. So let's see if it happens this time. If not, I've got like a prepared example. So this snake can kill itself. It's not going to. It's going to survive. Is it going to survive? Is it going to? Yes. No, it survived. OK. Well done, Snakey. Random snake is not perfect. If it gets into this kind of situation, it sees an empty square above it and an empty square below it, and it doesn't know anything about the fact that the move up is obviously stupid, right? It just sees empty square, yeah, maybe, and goes for it. Now, how to deal with this situation, right? Option 1, we could check, like, if we move to this square, how many free moves do we then have? But even with a snake this long, and snakes can get as long as you want if they eat lots of food, up to the point where they fill the whole board, it could be heading down a chute, which it will definitely die at the end of, but how many moves do you want to look ahead? Like, that's a question. Perhaps the approach that I took is simpler, which is you just click the retry challenge button and hope it doesn't happen. So you went like this, it died, sorry, snake. But it did at least, once I clicked retry and got them through this challenge. So we've got the 2 challenges so far, right? Don't die by running into the walls. Don't die by running into your own body or getting trapped by your own body in the corner. Actually, we haven't sorted that problem. We're just hoping for the best with that. The next challenge, challenge 3, and I'll run it because I want to get to show you what happens in challenge 4 as well, is avoiding other snakes. This one's pretty straightforward because actually this snake very rarely has any choice. Like, it just follows these tunnels, and it only has to make a choice at the T-junctions. And it chooses randomly, and it'll survive for 100 turns, no problem, right? Because any empty square and only empty squares are valid moves, right? So it won't try and move on to the other snake. So, well done. Good boy. There's a little animated version in case that didn't work. But random snake doesn't get past the 4th thing, right? Random snake does not care about food. And to be a snake that lives for more than 100 turns, you have to eat, because otherwise you're going to run out of health and dead. Just rerunning the challenge over and over and hoping that random snake goes over some food by chance is unfortunately too time-consuming. It was time to introduce a new strat as well as random strat. And this snake, I'm calling it sensible eater snake, because it doesn't just eat food like as soon as food's available. It waits until it's hungry and at risk of dying. So snakes can only move left, right, up, and down, okay? So when there's a snake here and food here, like, the snake does not care about Pythagoras at all. It needs Manhattan distance. Left, right, plus up, down distance to the food is how long it's going to take to get there. And if that's more than your health, you're going to die on the way to the food. So I put in a strategy that said, if we're getting close to the point where we will die, like, maybe we want to target reaching the food with 10 health left. Okay? So I added a bunch of new code about working out where the nearest food is, about working out Manhattan distances, about scoring moves that take us towards food if we're hungry, higher, and this probably like doubled the amount of code in the project, and I wrote it without any tests. Fine, sorry. And this happened, right? So it moves around randomly, and then when it feels hungry, which is probably around sort of turn 60 or so, it starts to head up to that food. And it's kind of like a fussy cat that it's hassling you for food all the time. And as soon as you give it the food, it's like, no, no, no. And then it dies, right? So I've written a load of new code here, Manhattan distance, find the nearest food, score things. I thought there was obviously a bug in the new code that I've written, and I went and I spent hours and hours looking at this code, and I did actually even write some tests at this point to try and diagnose it, and I stepped through, debugged it, and I just couldn't see the problem. And the problem was not in the code that I newly written. The problem was, and I've already said this out loud to you like 4 times, it only considers empty spaces as places that it can move to. So when it gets close to the food, it just goes, oh no, that's death. I'm not going there. So it's got this like, I love the way they seem like real animals. They really made me laugh when I realized, oh, stupid snake, the food's not death, food's health. So anyway, fix that problem. And now we've got a snake that can avoid dying by running into walls. It can avoid dying by colliding with its own body, unless it traps itself in a corner, which I fix later. It can avoid dying by running into other snakes' bodies, and it can keep itself alive by eating food when it needs to. So this snake can now basically manage its own existence until it's filled the whole board, and then it's going to die. But that, I feel, is like a happy death for a snake because it has become its own universe, and there is simply nothing left for it to conquer. So now the snake is basically capable of looking after itself, at least. Let's take it to the arena and fight other snakes after a short digression about algorithms. A couple of algorithms from the 1960s that are very, very helpful. So do you remember this situation, right? One way I talked about solving it was the look ahead and stepping through like a tree of game states to work out what's going to happen. Another simpler way of actually thinking about this is just like, how many empty squares are there in each direction? There's 1 if you move up. I can count that. Has anyone counted the other ones? There's 115, right? So it's an obvious choice. It's an 11 by 11 board, right? So it's an obvious choice once you've done that to just move into the bigger space without any look ahead. And the algorithm to do this is called flood fill, as made famous by MS Paint. This is, I tried to make a nice visualization of flood fill, and I couldn't do anything better than the Wikipedia animated GIF, so that's this. Finds the size of an open space by just expanding into it 1 cell at a time, keeping track of where it's been already. You can write this iteratively or recursively. It's actually probably about 40 or 50 lines of code. You have to keep track of state a little bit, and if you're writing it recursively, you have to do a lot of defensive copying, so maybe iteratively is better in Java, but when I wrote one in Clojure, recursion was cool. Well, anyway. Another useful algorithm is how to plot a route from A to B on a grid with stuff in the way. And that is best done, I think, with the A-star algorithm, which this is, again, the Wikipedia version of visualization of. Again, like recursive or iterative, this time it's trying to start from, here and get up to that green one, and it will eventually, there's a hole in the floor. Do it like that, right? So this is very useful for finding a route to food with stuff in the way. But what actually, and this one has got like dealing with like how much space is available to us with stuff in the way, right? But what is the stuff in the way in Battlesnake? It's just like other snakes. And snakes move every turn. So these have static obstacles, but in Battlesnake we have dynamic obstacles. And that's like an interesting twist. You don't really want to get into the game of predicting which direction other snakes are going to move in, because that's as hard as knowing which direction you should move in. But you can at least say the snake's tails are going to move out of the way every turn. So every time this A-star algorithm takes 1 step further forwards, we can sort of take off one of the obstacle squares. And that lets us do things like if there's us here and food here, and another snake like directly across like a barrier, we'll go around the tail end of it, because we know that the tail's kind of going to move out of the way as we do it. So that's a kind of, I guess, modified A star that took a couple of evenings to write, 0 minutes to write tests for because I didn't. And it's actually genuinely helpful because it is quicker to get the food, but it also avoids going around the head end of the snake, and that's the dangerous end of a snake, as any snake handler probably knows. OK, algorithm digression, finished. Let's go to actual battles of battlesnakes. Right? How do you win a battlesnake game? Right? You have to be the last snake standing at the end. So let's reframe the question. How do you become the last snake alive, I'll say alive, at the end? Well, how do you stay alive for a long time? You simply avoid dying for as long as possible. Right? So reframe again. How do you avoid dying as a battlesnake? We've seen a couple of ways of avoiding dying. Don't hit walls or obstacles. Don't run out of health. But once you can do those things, the very majority of battlesnake games end with a head-to-head collision between two snakes. And the rules, so that means like two snakes try to move onto the same square in the same turn. Right? And the rules there are based on the lengths of the snakes. And the lengths of the snakes are these numbers up here on the top right, 10 and 11. Right? Or you can just count them. So two snakes move onto the same square. If they're the same length, they both die. If they're not the same length, the shorter one dies, the longer one lives to die later. So that game that I've shown a couple of times on the slides ends a couple of moves after this, right? And we can see that the green snake is longer, it's 13 length, and the other one is 11. And there's a risk of a head-to-head collision, right? If they both moved onto that square in between them, the gray one would die. If they don't, well, it happens the gray one's going to die anyway because it's being shoved up into the corner and it has no way out as long as the green snake kind of continues to trap it. So, more strats for the strat engine. Try to be the longest snake, right? That's quite important because you can't be aggressive and you can't survive head-to-heads unless you're longer than the other snakes. So my snake has a strat built in now that says, we want to be the longest snake, and we want to be the longest snake by 2. So that's why it's 11 and 13 here, because if we're only the longest by 1, and we go for like head-on, and they eat on the way, it's death. So try and be the longest by 2. And then A-star path towards other snakes' heads, right? And actually, that's not very effective, I discovered, to my surprise, and you might know this as well if you have a spaniel or other kind of dog. I was going to say stupid, but no, the spaniels are lovely. I have a spaniel, and if you throw him something, he chases directly at it, which is not great because what he really wants to do is move to where it's going, but he doesn't do that, right? So I've got try to be the longest snake, try to move to A-star path to the space in front of the head of the current snake, and that sort of cut down on this like chasing other snakes around in circles thing. It's just my invention. I don't know, maybe 2 would be better, but it worked. So this green snake's current path, according to that, is it's trying to A-star path to the very corner. It's not going for the head. However, that is overruled by the fact that there is a potential head-on collision that we would win. So try to be the longest snake, try to chase other snakes' heads, and then if you get close enough that a head-to-head is actually possible next move, just absolutely go for it. Like, do not consider any other possibility. Take that as like a very high priority rule, because if it doesn't work, if they don't move on to you, and they won't if they're following the same rules as I am, then you're at least moving closer to their head anyway, so it's fine. Doesn't matter. So this is honestly like the sum total of how I built the world's okay-est Battlesnake. Well, I say the sum total. There are also like, I don't know, probably like 200 weird edge cases that I found on the way. So like just specific little situations that you can get into, which I put in like little extra rules about, oh, if it's exactly like this, then actually don't do that, even though it looks good, because you won't survive. What happens if 3 snakes are approaching the same square and one's longer and one's not, blah, blah, blah. There's like just an enormous number of, well, not very many hard-coded strats. Like I've shown you the main ones. There's a few other ones, like about hanging around in the center of the board if you've got nothing else to do, because that's safer than being in the corners. So random strat is actually out of the window now. Tons and tons and tons of weirdy little edge cases and loads of manual tuning of these strats. And also I gave the strats a concept of a weight. So each strat returns a number from 0 to 1 where it scores that, but I want some to be like considered more important, like the not dying ones are more important than the killing other snakes ones, right? So that's how I avoid death in three-way collisions, right? Because I don't want to go in there just to kill that one if this one's going to kill me. So that kind of stuff. And it's just incredibly complicated code, and it relies on the emergent behavior of like these strats, the hard, like magic numbers everywhere for the different weights between them. It's very hard to evolve and make it any better. So it's kind of stuck at being very okay. Never mind. Little note here. I work for Twilio. One of the things you can do with Twilio is send SMS with code. And one thing I try to do with this Battlesnake is every time there's like a /end request, the game's finished, send me an SMS. Like examine the payload, work out if I won the game, send me an SMS to cheer myself up about that, or at least like give me something to look at to add another edge case if I didn't. And what I found is that in the public Battlesnake leagues, you get put into a match every 5 minutes for 8 hours every day. So I turned it off again because Twilio can cope with that fine, but I do not want my phone buzzing every 5 minutes for 8 hours every day. That was several thousand, you know, every day. It was troublesome, very troublesome. There you go. That's the answer to the first question, like how I built the world's Okay-est Battlesnake. Now, I'm going to talk about, well, I'm going to show you a couple of tools, right? If you are interested in picking this up yourself, I would definitely say do so. I've put it at the bottom, the awesome Battlesnake. You can take this URL or just Google for awesome Battlesnake. It takes you to a repo with tons and tons of tools, blog posts, explanations of how to write better than OK Battlesnakes. And one thing that's like especially good on there is the Battlesnake board generator, where you can just sort of draw a situation and then copy-paste out of the website the JSON payload that corresponds to that situation. So you can decide a particular situation and actually test your snake on it, which is extremely helpful. Now, I talked earlier about the fact that this is a rules-based agent. And I don't know, man, if you look at the Battlesnake league rankings, you'll find that not many rules-based agents are near the top. Okay, so what is better than a rules-based agent? There are two like approaches that really dominate like the best snakes, and they're both like significantly more abstract, but they give you better results, and they're just like a new programming challenge. So why not? Tree search. And when it's talking about tree search, it means like the tree of game states. So the root of the tree is the current state. The branches correspond to like what different states could be next. And then from each of those, what states could follow that, and what states could follow that. My next Battlesnake is going to be a Monte Carlo tree search. I've already started it, Battlesnake. And then some people write Battlesnakes that use machine learning, supervised learning, where the data set is like games that have been played, or reinforcement learning, where it plays against itself and tries to improve from that. So, whom amongst us is familiar with Monte Carlo tree search as a strategy? Nice. Okay, so based on like lack of hands, I will just quickly talk through what a Monte Carlo tree search is, because it's kind of a fun thing to know about. And I'll give you a simpler example than the Battlesnake thing, okay? What is the most likely result of summing two random dice rolls? 7, right? You've been to school, I expect, most of you, studied probability theory, and you know that, no? And you know that 7 is the most likely result, right? You can do this analytically, but another way of doing it, and the sort of Monte Carlo style approach, is just roll absolutely loads of dice, or better, build a simulation of rolling dice, and just try it loads and see which one comes up the most often. And that's an easier approach to take for a less predictable kind of situation than rolling dice, right? Rolling dice is the simple example, but think of it as applying to searching through the tree. Like instead of rolling a dice for a random number, we're choosing a random next state to move to in the tree of move to next possible state, state to next possible state thing. So it looks like, the code for Monte Carlo looks like this so far. All familiar with this? So we need a dice. We need a die? We need a die? We need a dice. I can't remember. We'll get one anyway. And we need a way of storing the results, right? So I'm going to use a map from integer to integer, where the key is like the sum that we found, and the integer is like the proportion of times we found it, or like the total number of times we found it. And that can be a new... I have my fingers on the wrong place. Do not delete this class. No, absolutely not. This can be a new hash map, right? Cool. Now we need we need to give this a name, don't we? Silly me. Results. We need to run this trial a large number of times. Can anyone just give me like a large number? Don't say integer max value. 1,000. Cool. OK, so let's just do it in a for loop, because old school. And what do we need to do, right? We need to roll 2 dice and create the sum, right? So the sum is, let's get rid of these. Does anyone else do this just like putting in random extra lines all over the place with nothing on them? r.nextInt, 6-sided dice. I didn't specify that, but it is. Plus another one. And these actually generate numbers 0 to 5, but dice are 1 to 6. So let's add 2 just to account for that. And then I'm going to use a method that was actually new to me on the Java map interface to add these in, right? You can do results.merge. I don't know when this was added to Java. I don't remember it from like Java 4. The key in the map is the sum. The default value is 1. And the thing we do if it is not the default value, because there's always already something in there, is integer sum. I guess if it takes a functional object like that, it's probably a Java 8 thing. Yeah, cool. So I'm just going to try and get rid of this thing on the right, because we don't need to see that. So here we go. So we do 1,000 trials where we roll the dice, and then we stick them in this kind of probability map. And then I'm just going to do some like some Java-y stuff to print this out in order of most to least common, right? So results.entrySet.stream compare, no, sorted, isn't it? So each entry we want to sort by e.get value, but we actually want like the most common one at the top. So I'll do minus e.get value, and then we'll just print them. Sout tab, nice. OK, so this is a Monte Carlo solution for working out the number we all knew 10 minutes ago, which is 7. Has anyone seen a bug in this, or is it actually going to work? Hey, it's actually going to work. So yeah, we can see 167 out of those 1,000 times, we did get 7. So we can feel like somewhat confident that 7 is the best answer that we could have chosen to the question of what the most likely sum is. If you want more confidence, you increase this number. If you want less confidence, for some reason, decrease it. So like critical parts of this are a simulation of the thing we're simulating. So you need to, or I will need for a Monte Carlo simulation in Battlesnake to be able to simulate the rules, to know what possible next states actually exist, right? Some way of like aggregating the results as they come in, which I'm using results.merge here. And then some concept of like when to stop doing this. And we don't need actually for the Battlesnake to have like a fixed number of things, but we can do it on a time basis. So we know that our latency is, say, 30 milliseconds. We need a response to the server in 500 milliseconds. So maybe we've got about, say on the safe side, 450 milliseconds of work to do. So we can, instead of just making this fixed, we can say to do this until that point. And as long as this merge thing is sort of stable enough, we can just take the best value that we've got so far at that point and say that's our best next move. Another thing is like these simulations are entirely independent from each other, right? So they could be done in parallel, not on a T1 micro, because it's only got 1 core. But if I paid to win by getting a bigger machine, I could do these in parallel. The constraint there is that this has to be thread safe, which map.merge doesn't guarantee, but I suppose the implementation might, but hashmap doesn't. And so I'm going to use this as a bad example of something to experiment with Project Loom with. So Project Loom's a new threading library. No, it's not a library. It's part of the JDK, and it's It's virtual threads, right? So you should be able to create more threads, and they should be able to cooperate much better if they're I/O blocked, which none of these ever will be because it's pure CPU code. But hey, I'm going to use it to try out some of the new interfaces and new APIs from Project Loom, which is released in Java 19, September this year. Cool. That's my next snake, which is hopefully going to be slightly better than OK. If it reaches like 30% win rate, I'll be happy with that. 25, actually, I'll be happy if it wins anything. Don't kid myself. Right, so now the next and very last part is like, why did I write a Battlesnake? What's the point, right? You can tell I enjoy it, right? It's fun to have these little wiggly things and to anthropomorphize them and pretend that they're real animals and stuff. But this is a concept of something that I'm kind of more seriously into than messing around with snakes, which is about learning and like effective ways of learning new things, right? It's very important to have a safe space where failure is totally okay and there is no expectation of success in order to learn new things. Like if all you ever do is write production code, you're never gonna be fully able to like appreciate the possibility of trying something brand new that you're not sure if it's gonna work, and that's gonna limit your learning opportunities, right? So these were my reasons. It's a learning environment free from expectations of success. And if you're not bothered, if I've totally like turned you off from Battlesnake, I still think this learning environment free from expectations of success is something you should find and take away from this talk. I used it to try new algorithms, relearn stuff that computer scientists have known for 50 or more years about A-star and so on. New programming techniques. I wrote a Battlesnake in Clojure. I wrote a Battlesnake in Julia, which was kind of fun. Play with new Java features. I talked about a few new Java features on the way through, and to have fun. So please do give it a try yourself. It is actually, I don't know, I really enjoy it. And you can take part in leagues. There are different game modes. You can set up private leagues for you and your colleagues. I was talking to the organizers here about whether they're going to be able to have like for another conference they're organizing in the future, like a sort of prize, a league for attendees of that conference where they would give the prize at the conference. It's like a leading up to it thing. It's like, it doesn't have to be seriously competitive. There are prize money kind of tournaments for it. But I don't want to take it that seriously, so it's fine. Here's how. Go to play.battlesnake.com, sign up for an account, write yourself a web server. I deliberately have not put my code on GitHub because, like, firstly, it's embarrassing, but secondly, like, the writing it yourself part is like a really important factor with it. So, and it's not that complicated. It's an HTTP server with 4 endpoints and a bit of JSON stuff, and then the rest of it's up to you. And last thing before I say thank you is that, yes, Twilio's hiring in Poland. So if you feel like you would like to work with people like me for some reason, then by all means, check out twilio.com/jobs. And my lovely colleagues who are sat over there as well. That's all. Why isn't there a slide at the end that says thank you? Because that's what I want to say. Thank you for coming. Thank you for listening. And enjoy the lovely sunshine in Krakow from now on.